Welcome to this session. In this session, we have another problem testing on application of friction. So a block of mass 5 kilograms lies on a rough horizontal ground. So the mass of the block specified to be 5 kilograms. The coefficient of friction between the block and the ground is given by, so mu is 0.4. And then the other information is that a horizontal force P is applied to the block. So find the magnitude of frictional force acting on the block and the acceleration of the block when the magnitudes of force P is either 10 Newton, 19.6 Newton, and 30 Newtons. So the best way to solve this problem will be to write or to draw the sketch representing the forces acting on the particle, and then start analyzing each case differently, A, B, and C. So let's draw the sketch. So solution. So if this is the horizontal ground, let this be the block. And we've been told that the mass of this block is 5 kilograms. So we have frictional force F, and then we have a force P acting on this block. And as usual, we have the mass acting downwards. So the weight acting downwards, which is the same as mass is 5 times G is 9.8, which is 49 Newtons. And then usually in this case, the normal reaction is, so this is a frictional force, is always opposite to the weight. And so it acts 90 degrees to the surface. So then now, this is the case we have. So part A, the value of force P is 10 Newton. Now, when P is 10 Newton, then we know that vertical components, so we'll have R, if we take going up to be positive, upward direction to be positive, then downward negative. So R minus W should give us the net force in the upward direction. So, which is given by M times AY. And in this case, there's no vertical motion. So therefore, this acceleration is 0. So we have normal reaction minus W is the same as 0. Because mass times 0 is just 0. So which means that reaction is the same as weight, which is mass times acceleration, which is 5 times 9.8. And normal reaction will be 49 Newtons. Then using the relationship between, or to find the maximum friction, we get is mu times R, which will be mu for this case, or the coefficient of friction is 0.4 times normal reaction, which is 49. So this will give us 49 times 0.4, which is 19.6. newtons. So the value of frictional force acting on this object or between the surface and the block is 19.6 newtons. So A, the value of P is given as 10. So this is 10 newtons. And we have found that the value of this one is 19.6 newtons. So 10 and 19 shows that 19 overpowers the 10. So that means that when P is 10, so when P is 10 newtons, the friction will only need to be 10 newtons to prevent the block from sliding. And the block will remain at equilibrium. At rest in equilibrium. So that's what we have the case when P is 10 newtons. Now, a case when P is 19.6 newton, that's the case B. B, when P has magnitude of 19.6 newtons, the friction will be needed, will be at its maximum. Remember, this is the value we got as the maximum friction, value of 19.6 newtons to prevent the block from sliding and the block will remain at rest in limiting equilibrium. So that's what we'll have. Now, the case 3 or C, when P is 30 newtons, then the friction will be so because 30 is more than 19.6, so the friction will be unable to prevent the block from sliding, and it will remain at its maximum value of 19.6 newtons. So the block will accelerate from rest along the plane in the direction of P. This force P with acceleration A, where 30 minus 19.6 is the same as 5A. So this is the net force. So A will be 30 minus 19.6 divided by 5, we get 2.08 meters per square seconds. So that is how we solve that problem. Thank you.